Hello and welcome to my next self-study session. Today we're going to be looking at Leetcode number 76, minimum window substring. And so with this problem, we're given two strings, s and t, of lengths m and n respectively, and our task is to return the minimum window substring of s such that every character in t, including duplicates, is included in the window. If there is no such substring, we need to return the empty string. And so it also says that the test cases will be generated such that the answer is unique. So basically, we're not going to get a test case like S is equal to A, B, C, D, A, B, and then get T is equal to A, B, because then we have A, B appearing here twice. And so the answer would not be unique. So that's all that is saying. Anyhow, a substring is a contiguous sequence of characters within the string. And by contiguous, it just means it maintains its neighbors. So let's say we have this string right here, A, B, C, D, A, B. A substring in this would be A, B, C. And as we can see, it's a substring because the characters, they maintain their neighbors. So a substring in here would not be A, D, and B because the neighbors are not maintained. So that's all that means by contiguous. And let's look at an example. So if we have the string s is equal to Adobe Code Bank and t is equal to ABC, we're going to get an answer of BANC, bank, right? We see that looking at this string s, we have ADOBEC, Adobe with C in it. A, B, and C are all included. What we need in T are all included. We can also say that from code all the way to the end of here is another substring, but are these the minimum? So we would need to loop through, continuously check every time we get a substring that satisfies what we need. We would need to check the lengths and find the lowest one, and in this case it would be BANC. And for this example here, we have T is equal to AAA and S is equal to AA, and so because the length of T is greater than the length of S, then we would never ever satisfy the needs of T, and so we would just need to return the empty string. And so how do we solve this problem? Well, it kind of gives away the answer. The Leetcode actually labels this as a hard question, and it's labeled hard because I guess the coming up with the algorithm is not that easy. But we do have some hints, and we have a hint in the title itself of the problem, minimum window substring. But in the problem statement itself, it tells us substring and contiguous. And so whenever we hear words like substring, subarray, subsequence, these all have either order and or continuity, and thus we should consider using the sliding window pattern to solve the problem. So what is the sliding window pattern? Well, the sliding window pattern has two pointers, one on the left and right, which defines the boundaries within the data set, and normally the data set is just an array, and the two pointers are just the indices within our loop that helps us define that window width. And so that's just the basis of the whole idea of creating our window. But the sliding part, where does the sliding come in? It's the sliding actually comes in when as we loop through our data set, we keep moving that window either from left to right, which is the normal case, or from right to left. And we expand that window bit by bit, or we can even contract that window bit by bit. It depends on the problem, to solve some sort of problem, right? And so a common use case for the sliding pattern would be, let's say, to find the maximum subarray of length k within an array. So let's say we have this array with k is equal to 3. And we have this data set here, and we need to find the max sum subarray, and we can add these three together and then keep track of that as our max. Then add these three, 9, 2, and 3 together, compare it to what we previously found, add that as our max. Then we can add these three together, 2, 3, and 8, and then compare it to our max. And we just continue in that fashion until the end of the data set. But with the slide-in window pattern, what we can do now, we just need one loop actually, or 2 pointers, and we can add these three as normal, keep that as our current max in the first round. Then because we already have the sum of these three, 10, 9, and 2, when we slide over the pointer on the left, slide over the pointer on the right, we simply subtract the previous value and add this new value, the new value that's in the window. And we do our comparisons to keep track of our max, and then we slide over again, increment I, increment J, which would represent our left and right pointers respectively, and we simply subtract the value that's no longer in the window and add the value that's now in the window, and then compare it again. And so as you can see, we're just repeating what we're doing, and we're just moving over our window until we're done with our data set. And so that is the basic idea of a sliding window pattern, and we're going to use something very similar to this to solve our minimum window substring. So let's see what our algorithm looks like. So how does this work? Alright, so the algorithm looks like this. We set 2 pointers starting at the first index of the data set. The next thing we need to create 2 maps and 2 counts or counters. One map will represent the frequency for characters needed in T and the count for each type of character in the map. So if we have T is equal to A, and B, then we're going to have a map with values A equals 2, B equals 1, and then we're going to have a count of 2 because we just have A and B, 2 types of characters. And so the other map we're going to need is a have map. So while we are parsing through the string S, we are going to keep track of what we have found based on what we need. And then we're going to move the right pointer until the need condition has been met. That is the need count, the count discussed here. Once that has been met, we move the left pointer and we shrink the window, and we keep track of the lowest substring during this shrinking until the need condition is no longer met. And then we'll just repeat from step 1 until the right counter, while the right counter is less than the length of S. So if we have our string S, which we can just pronounce as Adobe Code Bank, and our string T with characters ABC, then we can set up our maps, our need map, and our have map, and our counters, our need count and our have count. And in our need map, it's just the frequency of each character in T, and our need count is just the amount of different characters in T, and in this case it's 3, and we just have one of A, one of B, and one of C. So it's just the frequency count for each character in T. And so for have map, they are initialized all at 0, and our have count also initialized at 0, because obviously we're going to be starting from the beginning of string S, and thus far we have not done anything. So the startup values are 0. And we have our 2 pointers, our left and right pointers, as is the case with sliding window pattern. And we're going to be starting at I is equal to 0 and j is equal to 0. When j is equal to 0, we have encountered the character a, which is part of our need map. And so 1, we're going to increment our value in our have map to 1, and it satisfies the condition in our need map. And because it satisfies the condition in our need map, we then can increment our have count. Does our have count satisfy the condition of our need count? No, it doesn't. So we continue with j. At j is equal to 1, we have a d. We don't need any d, so we can move on. At j is equal to 2, we don't need any o's, so we can move on. At j is equal to 3, we do need b's. So now we once again increment our map. Does it satisfy the condition? Yes, it does. Or have our mapping for b, or have map for b, is equal to what we have for b in our need map. And so we can now increment our have count. Does our have count satisfy the condition of our need count? No, it's less than. And so we need to continue with j. J is equal to 4, which is an E at 4, and we don't need any E's, so we continue. 5, yes, we do need C's. And so we increment that. And once again, we satisfy the condition of our need map. And so we're going to increment our have count. Now our have count actually satisfies the condition of our need count, and thus we can actually get a value, a result. 0 and 5. And we're going to get a length of 6, and we get that length because we're going to subtract I from j and simply add 1, and we're adding 1 because it's a 0 index array. And so the current length or minimum window substring is going to be 6. It says here, when we meet the condition, we need to move the left pointer. So now we need to move the window over. And since we're going to be moving this value, because I is currently at 0, we're going to be moving a out of the window. So now we need to decrement and decrement, because 0 is less than 1. So it no longer satisfied the condition. Therefore, we must decrement or have count. Or have count no longer satisfies our need count condition. And so because of that, we stop that and then we continue on with j. And remember, we just moved a out of the window. Moving it out of the window meant we moved over to d. And so we now at d at 6, we don't need any o's, so we continue on. 7, we don't need any d's. 8, we don't need any e's. 9, hey, it's a b, we do need b's, but it's more than our need, and so we're not going to actually increment our have count. 10, it's an A, and now it satisfies the condition. And so our have count also increments. And since it satisfies the condition, this gives us the opportunity to now check for our new minimum substring. And the new minimum is still going to be 6, because 10 minus 1 is 9, plus 1 is 10. And so we're still going to have a minimum of 6. And so We also know that when we meet the condition, we need to move over the left pointer. So the left pointer is now going to be at 2. So I is equal to 2. It's an O. We don't need any O's, but we're still going to be checking for the new minimum substring. So 10 minus 2 is 8, plus 1 is 9. It's still not less than. 10 minus 3 is 7, plus 1 is 8. Still not less than our 6 here. And at 3, it's a B. And so we are about to remove this B out of the window. And so we decrement that. And since it still meets the condition, we don't need to decrement our half count. And we just moved B out of the window. Now we're going to be checking for our new length. 10 minus 4 is 6, plus 1 is 7. It's still more than our minimum, so we don't do anything. And at 4, it's an E. We don't need any E's. And then it's going to be now 5. 10 minus 5 is 5, plus 1 is 6. And it's still not less than, it's actually equal to, so we're not going to be doing any updates. But we're just about to move C out of the window, and so we need to decrement that. And additionally, decrement our half count. And so since we just moved C out of the window, that means our I is at 6. Our J is still at 10, but since the condition no longer meets, we're actually going to be moving up our J. And it's an N. We don't need any N's, so we continue. It's 12. We do need C's, and so we increment that. And it meets the condition, so we increment our half count as well. And whenever we meet the condition, our half count meets the condition of our need count, we know that we need to increase the left pointer, but we're gonna keep track. So do we have a new minimum substring? 12 minus 6 is 6, plus 1 is 7, so no we don't, but we're gonna be increasing. 12 minus 7 is 5, plus 1 is 6, and that's still not less than, so we're gonna be incrementing as well. 12 minus 8 is 4, plus 1 is 5. So actually at this point, we're going to get a new data set. 8 and 12. We're going to get 5. And we're actually going to be incrementing as well this, or I, because the condition still meets. It's a B. Since the condition still meets, we're going to be continually checking. 12 minus 9 is 3, plus 1 is 4. So we're going to have 9 here. And we are about to move B from out of the window. So let's go down here a little bit. B is going to be moved out of the window. Since B has been moved out of the window, no longer satisfies the condition. And so whenever it no longer satisfies the condition, we actually need to move on with J. And since J is at the end of the string, our loop ends, and we will simply return this value as our minimum substring value of 4. And it's going to return these indices, 9 to 12. and 9 to 12 is B, A, and C. And that's pretty much it for this problem. So let's head over and see what this looks like in code. So here we're at in the code, and we have our main window method and our two parameters, our string s and our string t, which is what we need, and we're comparing this to our given string. And so we can have some checks, trivial cases. If s is equal to t, then we just simply return s. If t has a greater length than s, then there's no way that we can actually meet the needs of t, right? So we simply return an empty string as the question requires us to. These are our two maps, our need map, or have map. This is our have count initialized at 0, our found, and this only helps us, this is just for the helping us to return what is only if we found something do we ever want to use our sets, and otherwise we will return an empty set. So that's going to make a little bit of sense in a minute. So at our min set here, because we can actually, it's gonna have at least a length of the string s, so we just set it as that. And here we have our loop for catching the frequency of each character in t, and we start I and j 0, and our need count is this. Simply in JavaScript we use the map, the object, and we get the values, and the length of those values, that array, will be our need count. So while the right pointer is less than the length of string s, we will loop through and run our algorithm. So here we have, if we want to check if it's our need, if it's not undefined, which means we need it, then we are going to increment or have what we have in our have map. And then this is where we continuously check, is what we have just found, does it meet the need condition? If it does meet the need condition, if it's equal to, we increment our have count. And we need to run a check. Is our have count meeting the need, like our need count? Means we have found something. And then we need to check the length. If the length of where we're at is less than the current min length, then we found a new min length, and we get, we keep track. Because as we mentioned, we are going to continuously keep track of the lowest substring until the need condition is no longer met. So that's what this loop here is doing, until the need condition is no longer met. So here we want to check what we have at I. So if what we have at I is actually part of our need, we need to decrement our counter in our have map, right? And if our have map no longer meets our need condition, we also need to decrement our have count. And then we need to update I, that is, shrink the window. And we just continually do this until the end of the string s, until j, while j is less than the length of string s. Once it's over, we end the loop, and once we've found something, we just return the min set. Otherwise, we'll return an empty string. And so So if we run this, let's node 376, and there we have our bank, right? And we can also run these, though it wouldn't really be of a big deal. And so I just put answer there because sometimes when it's an empty string, we want to actually see that something happened, right? So here we have our t greater than the length of t greater than the length of s, and so it actually just it satisfied this condition, and so it simply returned an empty string. And that's it really for this. A little bit tricky, but I would encourage you to pay attention to words like substring, subarray, subsequence, contiguous, any words that denote order and continuity whenever we need to return parts of the data set in the form of a substring, subarray, subsequence. Then we can consider using the slide-in window pattern to solve the problem. And the best way to know whether or not this will work is to just draw it out on paper. Just solve it on paper using the slide-in window pattern, and then pull out the steps and see if we can come up with an algorithm. So that's pretty much it, and thank you so much for joining me on this self-study session. I'm looking forward to you joining me again. If you like this session, if there's any way in which I can improve, please let me know in the comments below. Like and subscribe, and I'll see you around on my next session. Take care.